Let's now look at the rules for differentiation. So find the derivative for each of the following. Now this is not using first principles, but this is using the rules. So constants, the derivative of a constant is 0. This is a simple one. Find f prime x if f of x is equal to 3. So because 3 is a constant, the derivative of a constant is 0. It means that f prime x will equal to 0. The next one, standard type, find the derivative, multiply the exponent by the coefficient, and subtract 1 from the exponent. Okay, so simply what this means is, let's work through an example. Find f prime x if f of x is equal to 3x to the power of 5. So, to find the derivative, f prime x f of x will become f prime x. And we're ready to find the derivative, so you multiply the coefficient here, which is 3, multiplied by the exponent, which is 5. Here we go, 3 times 5. Your base stays as x there, and you're going to subtract 1 from the exponent of 5. So that becomes f prime x is equal to 3 times 5 is 15, x to the power of 5 minus 1, which is 4. And this is your derivative of 3x to the power 5. The next one, third type. Right, find f prime x if f of x is equal to the cube root of x to the power of 5. Now, when you are working with surds in calculus, it is always handy to change your surd to exponent form. So we have done this previously, but it's very simple to do anyway. So you have x in the middle there. That will become your base x, and it's inside over outside. This will become your exponent. So it's x to the power of 5 over 3, inside over outside. So the cube root of x to the power 5 can be written as x to the power of 5 over 3. Now, you should notice that we have not changed the f of x yet. This is still f of x. We haven't changed it to f prime x in this line here because we have not found the derivative yet. You will only change f prime x when you are finding the derivative. So now, because we have it in exponent form, we can find the derivative. So now we change to f prime x. F prime x is equal to, and remember, we have a coefficient of 1 here, invisible coefficient of 1. So this will become 1 times the exponent of 5 over 3, which is 5 over 3 in the front here. And remember that you have to subtract 1 from the exponent. So 5 over 3 minus 1 becomes 2 over 3. So f prime x is equal to 5 over 3x to the power of 2 over 3. That is the derivative. The next type is squaring the binomial. So find dy dx if y is equal to 4 plus x cubed all squared. Right, so when you're finding the derivative of a binomial, you need to open out the brackets first. So we will square the binomial first. To square the binomial, remember, it's first times first. So 4 times 4 is 16 here. Then last times last, x to the power 3 times x to the power 3 will give you x to the power 6 there. And for the middle term, you need to say 4 times positive x cubed is 4x cubed, and you need to double it. So 4x cubed doubled is 8x cubed. Positive 8x cubed goes in the middle there. Now that you have everything opened up and separated terms, you can now find the derivative. So they asked us for dy dx, so we will say dy dx now is equal to, remember that 16, the derivative of a constant is 0, so we can ignore that. So we can work with the next term here. It's 8 times 3 gives me my 24 in the front here, and I need to subtract 1 from the exponent. 3 minus 1 will give me an exponent of 2. So 8x cubed, the derivative there is 24x squared. Now I go with the next one, plus. The coefficient of x is 1, so 1 times 6 will give me 6 in the front here, and I need to subtract 1 again from the exponent, so 6 minus 1 is 5 as my exponent. So the derivative of x to the power 6 is 6x to the power of 5. So dy dx is equal to 24x squared plus 6x to the power of 5.